Today we're looking at linear graphs. Now the word linear literally means like a line. It's even got the word line as the first four letters, and that should be an easy way for you to remember that a linear graph is just a straight line. Now it will generally in its formula have some x's, some y's and some constants, but it's important to notice that any of these actually could be missing and it will just affect what our line looks like. Now when we say a term in x, we just mean it has some x's, not x squareds or x cubes or anything like that, just maybe x, maybe 2x, maybe half an x, and so on. And if you need revision, a constant term is just a number. So for example, 2 is a constant because all it ever is 2, it can't vary. So we'll say that all of them are relations. Now you'll remember that a relation is just any set of coordinate pairs that we can graph on the Cartesian plane. And most straight lines are also functions. But they wouldn't all be, because a vertical line, something like this, will actually fail that vertical line test that we need a relation to pass if we're going to call it a function. Why? Well, there is a spot on the graph there where a vertical line will go right through the graph more than one time. In fact, it will be right on the line an infinite number of times. So it definitely fails that vertical line test an infinite number of times. Now, if we are missing any of these parts in our formula, if we're missing the x part, the y part, or the constant part, it will change the nature of the line. So let's have a look at a few different types of lines. This one actually has some y's, just one. It has two x's and it has a constant, 1. So it has all three ingredients. Now when that happens, your line will be a diagonal line and it will cross the x and the y axis somewhere other than the origin. That's what the constant actually will do to it. If it's missing a constant, then it will actually go through the origin, and we'll see lines like that later. Now, if it's missing the x part, but it has y's, then effectively it makes it a horizontal line. And if it's missing the y's, and it's only got x's and constants, then it will make it a vertical line. Now, people get confused with these all the time. Here's the way to think it through. This line y equals 3 has an infinite number of points along it. But let's just imagine some of the key points that are really easy to describe. This is 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, and I could keep going as though I'm counting along the number line, right? What do all those points have in common? Their y value is 3. 1, 3, 2, 3, 3, 3, 4, 3. And if I wrote them as coordinate pairs, you'd say, oh, they've all got the y value being 3. So if you're making up a name for this line, you're obviously going to say, let's call it y equals 3, because every single point on the line has a y value of 3. Similarly over here, x equals 1 is just the line where every single point on there is 1 comma something. So we've got 1, 0, 1, 1, 1, 2, 1, 3, and all those other infinite dots in between. 1 comma anything is going to be on that line. Now there are two common forms for linear functions that you need to know for this course. The first is gradient intercept form, and hopefully you've seen this sometime in year 9 or year 10. Now this form puts the y by itself on one side of the equation, and it puts the terms in x and the constant on the other side. But if you put them in this order, where you have some x's and then you have some other numbers, then the number of x's that you have, or in other words, the coefficient of x, equals the gradient of that line. And that's a really handy shortcut, because if you've got a line in this form, you can basically just read straight off the formula to see what the gradient is, and the other number that's left at the end will be the y-intercept. So that makes it really handy for graphing, as we'll see in a moment. We've also got general form, which you may or may not have seen. Now, general form says we have to get all of the terms on one side and have the whole thing equaling 0, which is left alone on the other side. Now here, A, B, and C are just constants, so they're just numbers. They tell you how many x's and y's and other numbers you've got. But there's a few exceptions here. C can be anything, but with the A, we say it has to be positive. So in other words, you get everything onto the side of the equation that makes you have a positive number of x's. So you wouldn't start with, say, minus 2x. When you're writing something in general form, you'd have 2x. And remember that you can move everything from one side of the equation to the other by either multiplying or dividing all the terms by -1, because that changes their sign. Or if you had a negative number of x's on one side, you could add that number of x's to the other side and similarly add or subtract all the terms until they've all moved across. Now, why should the a's be positive? Well, it's just a convention. And a lot of these sorts of forms are just ways that we can all be talking about the same thing and have our functions look instantly recognizable. The other condition is that b can't be equal to 0. So all that means is that you have to have some y's in your equation when you're writing out a linear function in this form. Now think about what would happen if you didn't have any y's. We just saw that a moment ago. You'd end up just with x equals something. That's going to be a vertical line, isn't it? Now, is that a function? No. And so if you're looking at forms of linear functions, you can't include something that's actually not a function. So that's why you're going to have some y's in it if you're going to call it a function. Otherwise, it's going to fail that vertical line test. Now, for this course, you should be able to easily rearrange equations in and out of one form or the other. And sometimes you'll want something in general form literally because a question has just said, express your answer in general form. Other times you'll want to change something to gradient intercept form so you can use that form to graph it simply. Now, something that you should add to your notes there is that A, B, and C should all be integers or whole numbers. So if you've got any fractions in your general form, multiply through, that means multiply all of the terms on both sides of the equation by the denominators so that you get rid of all of your fractions. So now let's practice changing a linear function that's written in general form into that gradient intercept form. The idea is to get the y's on one side on their own and the x's and the other numbers on the other side. So looking to get this positive 2y here on its own on the left-hand side of the equation, I'm going to leave it there. But reason that to do that, I've had to subtract 4x from this side, so I'll need to subtract it from the other side as well. And to get rid of this negative 6, I've had to add 6 on this side, so I need to add 6 on this side too. Now I'm close, I've got 2y, and what I want is just y. So if I'm halving the left-hand side of the equation, then I need to halve the right-hand side to keep it balanced. But remembering to halve both the parts. So halving this, I get minus 2x, and halving my 6, I get 3. Now this makes this quite nice and easy to graph because I can see that the y-intercept is 3, so find that point there. And I can see that I've got a gradient of negative 2. Now what does that mean? Well, negative gradients always go this way. As you read the graph from left to right, I think of it as a line that's going downhill as you read it. Whereas a positive gradient goes the other way. So as you read the graph from left to right, I think of something traveling along that line going up the hill. So negative 2 is a gradient that looks something like this, a rise of 2 for every run of 1. And you should have learnt in year 9 or 10 that gradient equals rise over run. So if I think of the steepness of the line as being 2, but 2 in a negative direction, I can now draw up my line quite easily. It's quite steep. And I can see that for every 2 boxes down that it goes across 1 to the right. So if I go down 2 and across 1, then I'm going to have a point on my line there. That'll be the point 1, 1. And here if I go down 1 and across, well, if I go down 1 instead of 2, I need to only go across a half. So I can see here that this will be the point 1 1/2. So you can use the gradient to actually sort of build your line and find points. You could also treat this as the bottom corner of your triangle there and say every time I go across to the left 1 box, I need to go up 2. So go across to the left and then up 2 and you'll have another point. And if you've got grid paper, it makes it a nice easy way to graph your straight line. Now let's convert a line that's in gradient intercept form back into general form. Why would we want to do that? Well, quite often we're asked questions that ask us to give our linear function in general form. So it's really just a way of showing that we can follow that process. Now there's 2 things we need to do. We need to get everything on one side and we need to make sure that the x's are positive. But we also need to make sure there's no fractions in any of our coefficients or numbers. So take your pick which thing you want to do first. I might decide to get rid of fractions first by multiplying everything by 3. That will give me 3y. And if I multiply 2/3 by 3, I just get 2. So I've got 2x here. And I need to also remember to multiply the 1 by 3. Now, if you struggle with that step, you can literally put on here 3 of these, plus I need 3 of these, and I need 3 of these to make sure that you remember to do 3 of everything. Next, we need to get everything on one side. Now, I'm looking and seeing that these x's are already positive on this side. So if I subtract 2x from both sides and bring the x's over here, they're going to be negative, and I don't want that. So I think it's better to subtract 3y from both sides, and that's going to bring the y's over to this side, because this is the side over here that has positive x's already. So let's go ahead and just subtract 3y from both sides. That'll leave nothing at all on this side. And over here, we write the x's first, then we write how many y's we have, and we've subtracted 3y, so that's how many we've got, plus 3. Now, that's completely fine. You can rewrite it round this way to have all of the stuff, if you like, on one side and the 0 on the other, but really you might as well stop there because this is the exact same thing as that. Now, we haven't necessarily made it any easier to graph by fiddling with it like this. We've just got comfortable with changing the form from one to the other.